All right, today we're going to talk about angles, segments, rays, parallel planes, and parallel lines. So on the notes here, the first term is angle. We're going to talk about that in a second. We need a few more things to do before we define an angle. So if we go here to segment, right, the definition of a segment is going to be part of a line that consists of two endpoints. So if we were to draw the endpoints like so, and then all the points in between them. And so a series of points by definition is a line, which we talked about in the previous lesson. So this would be an example of a segment. Now we can label a segment with capital letters, like so, like A and B. And that would be a drawing, a diagram of a line segment. Now if we wanted the symbol for it, what we do for a symbol is 2 points on the segment are written down and then a segment goes on top. So this would be the definition, the picture, and then the symbol of a line segment. We could also write the segment switching the letter order. So either order would be okay in this case. All right, for a ray is part of a line that consists of one endpoint. So if we were to draw it, has one endpoint and all the points on one side of the endpoint. So we can go out in any direction. So endpoint and all the points in one direction. Right? And I'm drawing 3 of these specifically to show an example because this is the definition, these are the pictures. But to give it a description, a name, to identify the ray, we need a second point. So I'm going to label all of the endpoints A. All of the other points I'm going to call them B. Okay? So now when we name an endpoint, when we name a ray, the first letter in the name is going to be the endpoint itself. Okay, so in all these examples, the endpoint is going to be A. The other point we use is just any other point that it goes through. So in all these examples, the other point it goes through is B. Now, similar to what we did for line segment, we have AB, but the difference is on top of AB, we draw an arrow going to the right. Now it doesn't matter if the ray in the picture in a problem is going up or down or right or left. We always draw the symbol of that ray going to the right. All right, now that we have a ray defined, we can now come up to angle because an angle is formed by 2 rays that share a common endpoint. So if we were to draw an angle, it would look something like that. All right, and we will talk about naming an angle in a future lesson, but for now that would be the definition of angle. All right, down here, opposite rays. This is something that will be quizzed on in class. So this is going to be 2 collinear rays. That means 2 rays on the same line. So if we had a line going that way, a ray going that way, and they make the same line, that's going to be an opposite ray. And the key point is this: they're on the same line, but that's the important thing. They share the same endpoints. So in this case here, if I called this point A, I need another point to give it a name. So in this case, this ray going this way would be called ray AC, and then this ray going to the right would be called ray AB, and those 2 would be opposite rays. That is an easy example. What's a little bit more challenging is when 4 points are used. Okay, so if we had 4 points here, so if we have A, B, C, and D, what is an opposite ray? So what would be the opposite ray to BC? So if I said BC, what's opposite to it? BC is going to the right. So to be an opposite ray, we need the same endpoint, but go in the opposite direction. So we're going to start at B and go opposite, which is going to be through A. So those 2 would be opposite rays. There are more answers than that, but that gives you a couple different examples on opposite rays. Okay, so now we're going to look at parallel lines. And most students have come across parallel lines in the past and know that they're lines that do not intersect, right? And we can draw parallel lines like so. But we can't assume they're parallel unless the problem tells us or there's some symbol. And the symbol that we need is typically these little arrow marks, right? Now sometimes in directions on problems, we can name lines with small letters. So you may see directions that look something like this. And what this interprets as line M is parallel to line N. So this would be the symbol, and then this would be the picture with the marks, proving that they are actually parallel lines. All right, now skew lines are a little bit trickier to draw on the board, but they're going to be lines that don't intersect. But different than the parallel lines, skew lines are in different planes, right? But even if they are in different planes, they cannot actually be parallel either, right? So if we kind of look at this eraser, okay, this eraser is in the shape of a prism, right? So this front part of the prism is a plane. The back part of the prism is a plane. So if I wanted this bottom front edge, and I want a skew line to this, right, it cannot be parallel. So any line that's going left and right, on this eraser, like the top, that would be parallel, that would not be skew. The back part, this would be parallel, that would not be a skew line. And even the bottom edge here, those three would be parallel and not skew. The other part is they can't intersect. So with this bottom line, the line going up intersects it, this line going up intersects it, the line going back from it intersects it, and so does this one. So the remaining lines would be the skew lines. And in class, what we talked about doing is identifying the segment that you want, and then crossing off the various segments that intersect or are parallel. And we'll go through an example of that in just a second. All right, parallel planes are planes that do not intersect, just like parallel lines, except we're talking about planes. All right, so now let's look at some examples. All right, so this is an example of an angle, and again, an angle is two rays that intersect with a common endpoint. So what they want to do is, in this particular angle, what is one of the segments? One of the segments is AB. The other segment is going to be AC. Now, because it's a segment, we can also write them backwards. We can say BA, or we can say CA. All right, now let's talk about segments on the right problem here. The only segment we have in this case is JK, or we can call it KJ, your choice of how you want to do that. All right, if we go to the angle, now we know an angle is made up of two rays. So one ray is going to be AC, and the only answer for that is AC. We cannot switch the order. The other is going to be AB. Those would be the two rays in that particular diagram. If we go to the right side, there is two rays. One ray is ray JK, and the other ray is KJ. Now these two are switched because they're completely different. So here is JK, and here is KJ. And that's why they're named that way. We cannot switch these up, because again, remember, the first letter has to be the endpoint. So this would be the endpoint of that ray, this would be the endpoint of a different ray. So do not get confused on that. Now, are JK and KJ opposite rays? They are not. Why? Because the J and the K are different. They have different endpoints. So by definition of opposite ray, they cannot have different endpoints. So these are not opposite rays. Okay, here's an example that will look very much like your quiz, right? So make sure you know how to do this type of problem. So here, if we want to find segments that are parallel to Rn, the first step I want you to do is lightly trace the segment. So here we're going to trace Rn. Now because we're dealing with parallel lines, we want to also trace segments in the same direction. Okay, so in this example, Rn is going left and right. We want to trace any segment going left and right. So in this case, these are going to be the three other parallel segments. And so our answer to this would be JE, OS, HT. Those would be your three answers for that particular one. All right, now if we wanted skew segments, here we go. If we want to skew segments, the first step is going to be the same. Trace the segment. Okay, so we're going to trace it. Now by definition of skew, we can't have anything that intersects it. So what I'm going to do is cross off any line that intersects that particular segment. So I'm going to cross out the intersections. All right. Now the next step is going to be to cross off any parallel segments. So because this is going up and down, we want to cross off anything that also goes up and down. And so that leaves us with a few answers. So right here we see OR is not crossed off. So that would be a skew line. We see HJ is not crossed off. So that would be a skew line. We see JE is not crossed off. That would be skew, and so is RN. Okay? And so that's how we would identify skew lines. Now if we talk about parallel planes, we want two planes that aren't touching each other. So in this case, what we want to first do is identify a plane by front and back, because those two planes are going to be parallel to each other. The left plane will be parallel to a right plane, and then the top is going to be parallel to the bottom.
Sienna Heilman, will you please report to the front office for a moment? Sienna Heilman, come to the front office for